So I'm going to go to Visual Studio. Yeah, it looks like I closed it. Get it going again. I know I'm going to need my boilerplate, etc. Wonder if I could just make a sample solution that was in a zip file and just keep opening it that way. Make a new one. Anyways. By the way, everybody's exam should be graded. So if you want to eyeball it, roll through it, you probably already know the answers based on the lecture on Tuesday. But look at your own. Make sure I didn't misgrade anything. Alright, so make a new lecture. What lecture are we on anyways?
Lecture Papa?
Yeah, that's right. You told me last time that's what's going to be. Lecture P.
Oh my goodness.
What is that?
One thing I find annoying about my class is you get headaches.
Oh yeah? That doesn't sound good.
Yeah, especially because of my eyes.
So if you remember what a class is some data and then some functions which are known as methods that use that data. But this time we're going to put our class, no we're not, I don't want to make it too complicated. Let's wait up for that. So I'm going to make a new item, call it Lecture P. Alright, so I'm going to class, I'm going to put it above main. And we're going to call this block. Class block is going to have three members, height, width, and depth, or X, Y, and Z, right? So class block. It's got three pieces of data. They are public pieces of data for now. We could change this so that they were so-called private, meaning that they could not be changed by anything outside of the class. So public, colon. And are we going to support fractional? Do we need to make the X, Y, and Z doubles or just ints? Why not just ints? Int X, comma, Y, comma, Z, semicolon. These are called instance variables. Instance, they are part of the class and they can change for every object we make. One block could have values 1, 2, 3. The next block could have the values 10, 20, and 30. So they change on an instance by instance basis. You could also call them member variables. Now, let's make a function, a method that sets those values. It doesn't need to return anything because we're just setting, right? I'm going to say, yo, your width is 10, your height is 12, whatever. It doesn't need to return anything. So void space set values, parentheses, int x, comma, int y, comma, int z, in parentheses, curly brace. And now we're going to set the values of our instance variables using the this keyword. This hyphen greater than x equals x, semicolon. This hyphen greater than y equals y, semicolon. This hyphen greater than z equals z, semicolon. And What do we care about our block? Maybe we care about the volume and the surface area. Well, how do you calculate the volume? It's just x times y times z. And since these are all declared as ints, we could make the return value an int. We should have made them doubles, but whatever. So int space get volume with a capital V, parentheses in parentheses, because it doesn't need any parameter variables. We're getting the value of these three things multiplied by each other. So open curly brace, and I'm just going to say int r for like return value equals this hyphen x hyphen greater than x multiplied by this hyphen greater than y multiplied by this hyphen greater than z semicolon, and then return r. Now the surface area of this is going to be 2 times x plus y times 2y times z, something like that. Int get area, parentheses in parentheses, semicolon, int r equals 0, r plus equals 2 times. Now you do not have to use the this keyword all the time. For set values, you had to because our parameters were named the same thing as our instance variables. So I could just say 2 times x times y, like that. Or I could use the this keyword, which I prefer. So 2 asterisk this hyphen greater than x times this hyphen greater than y semicolon. Now I need to do the same thing for x times z and y times z. So I'm going to speed things up by copying and pasting that line. Make that r x times z, like that. And then the next one's going to be y times z. Right, because the surface area, it's got 6 sides. We just need to figure out the surface area of each side. Multiply it by 2. Add them all up. So I'm going to take that line, copy and paste it, and make it say y times z. Then lastly, return r. So that's our code so far. I mean, we could zoom out and see the whole thing. Then I'm going to zoom back in. All right, let's create a block. Block B1 equals new block, parentheses in parentheses. We have made a block. And I needed to actually put an asterisk here. Block asterisk B1 equals new block. This is a pointer to a block object. We haven't talked about pointers. Well, we're talking about them now. A pointer, it contains an address. It's a reference to a memory area. This memory area contains a block object. Let's create a second one. Block asterisk B2 equals new block, parentheses in parentheses. Now, let's set the values for them. So B1 hyphen greater than set values. My first block is just a 2 by 3 by 4 block. And then B2, it's got different values. Set values 5, 6, 7 in parentheses, semicolon. Except I accidentally called this one P2. That was a mistake. I meant B2, so I'm correcting that. So, let's print some information out. Cout less than, or how about we define these? Int area1 equals B1 hyphen greater than get area, parentheses in parentheses. Int area2 equals B2 hyphen greater than get area, parentheses in parentheses. We're going to do the same thing for volume 1 and volume 2, or just VOL1 and VOL2. Int VOL1 equals B1 hyphen greater than get volume, parentheses in parentheses. Int VOL2 equals B2 hyphen greater than get volume, parentheses in parentheses. And then we can print that information out. Cout less than quote block 1 area equals space end quote less than area 1 less than ENDL. And with some judicious cutting and pasting, I'm going to make it say block 1 volume equals and block 2 area and block 2 volume. So copy and paste, copy and paste, copy and paste. So this is going to be volume 1. Wait, no, block 1 volume less than vol 1. Block 2 area should be area 2. And block 2 volume should be VOL2. Let's run it and see what happens. The stuff we're doing now is the plus part of C++. The regular C language did not support classes and objects when it was invented in the 70s. C++ came along in the 80s. All right, and so our 234 box has an area of 52 and a volume of 24. I believe it. I'm not going to take the time to check it. And block 2 has an area of 214 and a volume of 210. Probably be a good point now to stop and see how y'all are doing. You don't need to hurry too much. I'll pause and make sure y'all are doing good. Well, firstly, let's find what memory address those things are. So just cout less than quote B1 is at end quote less than B1 because it's a memory address less than ENDL. And then copy and change those to B2s. B2 is at less than B2. We're going to see what memory address those guys are hanging around at. There they are in hexadecimal. I'm not going to figure out what those are, but there they are. Block 2 is a little bit later in memory than block 1, which makes sense because block 1 was created before block 2. They're a lot further apart than I would have expected because they were only containing 3 ints, which is 12 bytes of RAM. That's all right. Let's print out the address of a specific element. I'm not sure this is going to work. Firstly, let's print out the value of x for each one. So cout less than quote B1 x equals space end quote, less than B1 hyphen greater than X, arrow, arrow, ENDL. But now we want to print the address of that variable. We're going to use ampersand. Ampersand means address. Cout less than quote, B1, stop covering it up, X is at space end quote, less than B1 hyphen greater than X, but put an ampersand in front of it. That means I want to know the address of that specific variable. Less than ENDL. And then just copy and paste those things to change them to B2, right? You know what, just for funsies, print out Y and Z, right, for B1 or B2. All you have to do is copy and paste and make it say B2 Y equals, and change that to a Y. B2 Y is at, and change that to a Y. And do the same thing for Z. B2 Z equals, make a Z there. And B2 Z is at, make a Z there. I'm not quite sure what this is going to do. I'm looking forward to it. I'm going to run it and see. There they are. B1 is at 00CAB1B8. Completely different address than it was last time. And notice it's saying that X is at the same address. Well, that's because X was the first variable in that block. How about B2? B2 is at this address. It's at address CAB200. And so BATX is at 200. Y is 204. And Z is at memory address 208. Now, why are those four apart? Why is it X at location 200, but Y is at location 204, and Z is at memory byte 208? Why could that be? Why are they all four apart? How big is an int? Y'all just took an exam, you know. 4, right. What if we change these to longs? How big is a long? If we come up here and we change that to long, what is long? How many bytes are a long? Excuse me, long. 8. They're not going to be 4 apart anymore. They're going to be 8 apart now. Right? X is at 90. Y is at 98. And ignore the fact that it went to A0. You know, these are hexadecimal values. So anyways, 9098. They're now 8 apart. What if they were just characters? Characters are really itty-bitty. So if I made these char rather than ints or shorts or something, then when I ran them, they'd be closer together. Ooh, look at that. Garbage. Okay, that didn't work.
Garbage.
How about unsigned int? No, unsigned short. There we go. Shorts are smaller than ints, or at least I think they are. I think they're 2 bytes. So when I run them now, A, B, or X, Y, and Z should be 2 apart, and they are. It's hard to read, but D8 and then 2 past it is DA, and then 2 past that is DC. What if we wanted to know how big our object was? We would use size of. We could use size of to figure out how big a block was. And I'm pretty sure that you didn't get a chance to type all this in before I started running it. But let's just print out the size of a block. Size of a block is space, end quote, less than, size of, parentheses, capital B block, in parentheses, less than ENDL. I'm going to add the word byte to the front of it because that's what we're talking about. The byte size of a block is. And I needed a semicolon at the end, which I originally forgot. So a block is 6 bytes long. Why is it 6 bytes long? Because X, Y, and Z are shorts, 2 bytes each.
Mine's 12. Oh, wait.
Yeah, yours are ints. So ints are 4 bytes. So when I come back up here and I make these ints, the size of a block is going to be 12. Yep, exactly. And what if I come up here and I change them to longs or doubles? Well, doubles are 8 bytes. So the size of a block is now 24. 8 times 30.
Long on purpose.
All right, that may be just about enough talking about classes today. But you did see, one more thing I want to add is just let's print out the dimensions of one of the blocks. C out less than, size of B1 is, space end quote, less than B1 hyphen greater than X hyphen or greater than quote space quote or quote comma quote, and then on the next line, or you could put it all on one line if you wanted to, less than or less than B1 hyphen greater than Y arrow quote comma quote, and then one more. Let's print out Z less than B1 hyphen greater than Z less than ENDL. I feel like rearranging the order of these. I'm sorry to be so picky, but I want all of the equals to be underneath each other and all of the ats to be underneath each other. So I'm just going to do a little bit of cutting and pasting. You don't have to do this. But I want that one to be there and that one to be there.
Yeah, we're doing this
There we go.
advanced object-oriented programming.
Yep. All right. Okay, I like the way this looks better, right? B2XYZ is 567, and the addresses of each one of those variables, 9098 and A0, because I made mine doubles, so they're 8 bytes apart. So the size of it's 24, and the size of B1 is 2, 3, and 4. All right. Let me stop, make sure everybody got all that typed in, because we sure did type in a lot. Alrighty. Well, that was fun, but I think we're done with blocks. Except, wouldn't it be fun to make a whole bunch of blocks and print out their volumes? We're going to use a for loop for that. So for int I equals 1, I is less than or equal to 10, I plus plus. So we're going to create a 1 by 1 by 1 block, and a 2 by 2 by 2 block, and a 3 by 3 by 3 block, and so on, and print their volumes. So I plus plus, close parentheses,
I plus plus.
block, I'm just going to call this one PB. It's a pointer to a block, but I need an asterisk in front of it. Block PB. No, I'm not. I'm going to show you a different syntax. No, I'm not. I don't want to confuse the issue by showing two different syntaxes in the same lecture. So block asterisk PB equals new block, parentheses in parentheses. Now we need to set its values. PB hyphen greater than, set values, parentheses, I comma I comma I. So the first time it'll be a 1 by 1 by 1 block. Now let's just get that volume. int volume equals PB hyphen greater than get volume, parentheses in parentheses. Let's do the area as well. Int area equals PB hyphen greater than get area, parentheses in parentheses. And now we're just going to print these variables out. Cout less than, quote, edge, like the edge length, equals space end quote, less than I, less than, quote, comma, nah, let's move that down to the next line. Volume equals end quote, less than volume.
Oh, what?
And on the next line, less than, quote, comma, area equals space end quote, less than area, less than EMBL. And there we go. I'll bring the code back up, but if the edge length is 1, the volume is 1, because 1 times 1 times 1 is 1. And the area is 6, because it's got 6 sides. If it's a 2 by 2 by 2, its volume is 8 cubic meters or whatever, and its area is 24. And so on. I want you to change the for loop to display volumes, edges 2 through 20, stepping by 2. So it's going to be I plus equals 2 rather than I plus plus. So modify that for statement right there to make it start at 2, go through 20, and upgrade itself by 2 each time. So you're just going to have to modify that for statement.
2 and it needs to be greater than or equal to 20.
Yep.
And then run it.
So come over here. I want you to start at 2. I want you to keep going while you're less than or equal to 20, and I want you to increase by 2 each time, plus I plus equals 2.
Oh wait, I screwed up. I made I equal to. Just do 1.
And there we go, right? So our edges are 2, 4, 6, 8, all the way out to 20. Alrighty, so let's go back to our PowerPoint now. I think we're about done here with this particular part.
Flags.
Are you at the Java PowerPoints or?
That was the Java PowerPoint. I'm going to C++ now.
Yeah.
Might as well come in and. Oh wait, would it be too late to learn Java from your class?
All you have to do is come in at 7:05 and you can sit through the Java class. Parker's already doing it. But, all right, you're making decisions. That's definitely not the right PowerPoint.
We're on chapter 5 now,
Yeah.
and there's 20 chapters? Yeah, we need an advanced C++ class.
Yeah, we do.
This is it right here.
No, it's not. This is Intro to C++ language.
Yeah, but we just did a whole bunch with classes and pointers, so we're doing more than mere intro. All right, so the for loop, we know how it works. We've done for loops now. You have your initialization step, the test step, and then the update, like I plus equals 2 or I plus plus went there. So initialization, int I equals 0 or 2 or 1 or wherever it needed to go. And then the test was keep running while I is less than 10 or 20 or whatever. I is less than or equal to 10. And then the update is I plus equals 1. Or excuse me, I plus plus or I plus equals 2 or whatever you want. And then you put either a single statement or a block. Now when people were trying to figure out the 3 errors in the code, one thing that people said over and over, and it's not really an error, well, I understand why you put it because you had to find 3 problems, right? And so you would list, whatever you spotted. But it looked like this. If something, or no, it was an if statement. If x equals 3, semicolon, and then it had something else here. I forget what. Else, and it had something else here. So one of the problems is that there was only one equal sign. Needed to be 2. Another was that the semicolon needs to be removed. And the third one, well, it's not a problem, but people said it was. No braces after the if and else. That's not a problem if your block of code is only 1 line long. This is good code. This is also good code. So the fact that there were no braces, not a problem. But if the block of code is more than 1 line long, it is definitely a problem for there to be no braces. Like if we were going to print 2 things out. Now it's a huge problem that there's no braces.
Because it will say, we're not going to compile it.
Yeah, it wouldn't compile because it's treating it like this. Right? Only the first statement after the if statement is considered to be the body if you don't have braces. And then the rest of the syntax is just totally messed up, so it's going to give you a compilation error. And the third error actually was the fact that there was no CIN. So here's a loop that's going to print out hello 5 times, starting at 1 and keep going while I is less than or equal to 5. So 1, 2, 3, 4, 5. What if it started at I and went while count was less than 5? How many would it print? 4, right? 1, 2, 3, 4, and it would stop when count was equal to 5.
Hey Parker, take a look at my computer. I changed it to 200.
So let's do a nested for loop that's going to like print out 1 o'clock, 1:15, 1:30, 1:45, 2 o'clock, 2:15, and so on. So let's go back here, and we're going to print out a nested for loop. So see, let's declare, for int the hour of the clock. We're going to start at 1 o'clock, semicolon. We're going to keep running while hour is less than or equal to 6, semicolon. Hour plus plus, because we're going to go up 1 each hour, right? 1 o'clock, 2 o'clock, 3 o'clock, 4. Sounds like an old 60s, 50s song. Alrighty. Inside it, we're going to have a minute counter. And it's going to start at 0 and go up by 15, right, for 15-minute intervals. 0, 15, 30, 45. So int min, or minute if you want to use the whole word, is equal to 0. Keep running while it's less than or equal to 45. So minute less than equal 45, semicolon, and it's going to go up by 15 each time. Minute plus equals 15.
I'm going to do it long.
Alrighty, now we need to actually print. So we're going to see out less than the hour, less than, quote, colon, end quote, less than, minute, less than, ENDL. Now, it's not going to look perfect. And what do I mean by that? It's not going to show 0, 0. It's just going to show a single 0 because we're not using IO manipulators. But it'll be close enough. And there we go, right? 1 o'clock, 1:15, 1:30, 1:45. 2, 2:15, 2:30, 2:45. And so on. All the way down to 6:45. I'm tempted to include the I/O manipulators and to get this to work, but that's too much trouble. Now, something you will see in C programming that you don't see in C++ is instead of using cout to use the printf statement, if we use printf, we could make this look a lot prettier. Now, you haven't seen printf unless you've taken a Java course. That would look like this. Printf, parentheses, quote, %d, colon, %02d, \n, end quote, comma, hour, comma, minute, in parentheses, semicolon.
I have a question.
Yes, sir.
So the whole notation to the left, that helps us find the position of each of our hour minutes.
Yep, this is a placeholder right here. I'm going to change this a little bit. You don't need to do that, but the hour is %d, and the minute is %02d. Now that 2 does not refer to the fact that this is the second variable and this is the first one. Tell you what, I'm going to take that 02 out for now. Let's make sure it works, because if I'm doing this lecture and this crashes or something. Okay, see, the hour is 1 and the minute is 0. The hour is 1 and 15. So these 2% things are placeholders that get filled in by these two variables.
And why is it necessary to have those placeholders?
Well, what if we took them out?
It'll crash.
Well, it's not going to work. It's not going to look good. Let's take a look and see if it even runs. Might run. Can't say it won't. All right. Without the placeholders, those variables don't get stuffed in there. It's like you're getting a plate at dinner, but there's nothing on the plate because there was no place for it. So I'm going to put the %d back there and the %d back. Well, I'm going to change it now. I'm going to do this %d \n. That's what my formatted print statement looks like. That's what the F stands for, is formatted. All right, and so it prints 1, 0, 115, 130, 145. 2, 0. We're getting close to the output we want, but I want it to say 0, 0. And it's not showing that. So I'm going to say I want you to occupy 2 spaces. But I want you to have leading zeros filled in. Because if I don't put that 0 there, here's what it looks like now. Close, right? 1, 0, 115, but I want 2 zeros there.
So it needs a 0.
So I'm going to put that 0 in front of the 2 to tell it that I want all the blanks to instead be filled in with zeros.
So those placeholders just tell you what type of number value positions you put.
Exactly. And in Java, you saw us using %f. %f works just as well in C++. C invented this format. So instead of a space between them, why don't we put a colon so it'll look, you know, like real times. Just a second. And then now we have 1 o'clock, 1:15, 1:30, 1:45, all the way up to 6:45. All right, I wanted y'all to see printf, because if you go out into the real wide world and you start looking at C and C++ code, they may not be using less than, and greater than. Those are kind of idiosyncratic to C++. And so you won't be using them in other C-based languages like C#, or languages that borrow the syntax of C++, like Python and JavaScript. So I wanted you to see this syntax. And like Parker said, you can print out things other than decimals, other than integers. %d stands for integer. %d means integer. %f means float.
Oh, okay.
Yeah.
So whatever you define your variables to be, whatever type of unit you use, you have to call that unit. You basically have to call that unit, and that helps you find the position of each of those. So that's
Yep.
like That's like a X. Isn't it like a XY?
Yeah,
unit?
yeah. I mean, we could make as many placeholders as we wanted to, as long as we had that many variables to fill in.
It's like you have a coordinate and you're just trying to plot the point on the graph. But
Yeah. Okay, so here, above system pause. Oh, and you needed my help. I'm sorry. I'll be right there. Float f equals 1.0 divided by 7.2, something like that. Who cares what it really is? How about float f is equal to m underscore pi? Semicolon. And now let's print that out. Print f, parentheses, quote, pi equals % dot 4f. That's going to print pi out to 4 decimal places. \n. How many placeholders do we have? We have 1% sign, so that means we have 1 placeholder. So let's print out f. You know, that's kind of dumb. Delete that float f line and just print out pi right here, right? m underscore pi right there. And there it is. Pi is equal to 3.1416. If I want more decimal places, I can get them. If I change that to 0.8, the precision changes. Now, honestly, but I guess it's because I grew up, you know, programming like this rather than using C++ with less than and greater than. I like this way of formatting my data rather than using the IO manip header file and using setw and min and set precision.
well, yeah. Okay, so this is just a different method of trying to call
Exactly.
a unit and trying to actually trying to find where it is
Hold
or
on. I
to
need to
space
change
it
the
out.
while loop
right?
back.
Yep. All right, so let me pause it and make sure everybody's going okay. So I'm going to change my clock so it starts at 1, but it goes all the way to 23. Or we could even start at a 0, right? Because this is 0 midnight. So there we go. Now when I run it, see, these aren't lined up. What if I'm a real stickler for things lining up? Well, then I could use the width specifier. I can come over here and say I want it to be 2 characters wide. Or I mean, heck, I can make it 4 characters wide, but that'd be stupid because we don't need 4 characters to hold 2 numbers. But that does it, right? Now they're all nicely lined up. And if you want that leading 0 there, you know how to do that. Where would I put the 0 in this string?
Before the 4?
Yep. So %0 4D means padded out with up to 4 zeros.
C#?
There we go. Yeah, you can do this kind of stuff in C#. It's a little bit different, but same idea. And this syntax is exactly the same if you're going to use Java. And if somebody showed you this syntax in Python, it'll look very familiar to you there as well. Okay, now I don't want that many zeros, so I'm going to lower it back down to 0, 2, because we only need 2 zeros, right, rather than 4. There we go.
Wait a minute, is that 24 hour?
Yep, it's going from 0 to 23, so that's 24-hour military clock.
Meet me at 1300 hours.
Yeah. All right. Definitely not on chapter 4.
Wait a minute. What
So
now?
when to use the for loop? If anything involves an initialization, a condition to stop, and an update, that's a good use for a for loop. I would say anytime you need a counter. The for loop is a pretest loop, just like Python, because the test happens before the code. What do I mean by that? If we wrote our loop and we were feeling particularly brain dead that day and we wrote it like this, for parentheses int I equals 10 subscript and keep running as long as I is less than 5, semicolon, and add 1 to I each time. And then printf parentheses, in parentheses, semicolon, hello, backslash n, end quote, right, like that. How many times is it going to print hello?
3 times.
We didn't put I minus minus in here, so it's not going to start counting down.
Ooh,
I is 10, and it's going to keep running as long as I is less than 5. Well, is I less than 5?
no.
No, it just like an if statement. It doesn't go in here at all. We're not going to see a single hello show up. And we didn't. That's because it's a pretest loop, just like while. If this test doesn't work, it doesn't even go in there. So while and for are pretest loops. If the condition is false, to begin with, the body is never executed. Do loops are different. Do loops are post-test. Like this. Int I is equal to 10, semicolon. Do, open curly brace, printf, parentheses, quote, hello, backslash n, end quote, in parentheses, semicolon. As a matter of fact, let's print out the value of I. I is an integer, so we need to put a placeholder. And what kind of letter are we going to put there, D or F? We use %f for floats, so %d, end quote, comma, I. And then let's add 1 to I plus plus. And we want this to keep repeating as long as while I is less than 5, in parentheses, semicolon. That's a slightly different syntax. Python doesn't even have do loops.
In fact, this signal control while loops are harder to do in Python, right?
Yeah. Do loops. You can jigger. You can write any loop possible with just while loops. Your language does not have to have for loops or do loops to get the job done, but they can make things a lot easier when you need them. Okay, now why did it print hello 10?
Because I is 10.
Because I is 10, there's nothing from stopping it from getting in here. And so it prints 10. If we set I equals to 0, how many times is it going to print hello?
10 times.
Well, this is not I less than or equal to 10 anymore. It's 5. So going from 0 to 5 is going to be 5 times. And it did. Hello, 0, 1, 2, 3, 4. So when do you use each kind of loop? Use a for loop for counters. That's the best use for a for loop. Use a do loop if the body has to be executed at least one time, no matter what. And then otherwise use a while. And you can use for loops for other things other than counters, but typically that's what you think. Oh, I need something to count from 1 to 10. I'm going to use a for loop.
I tried signal control loops, and they're hard to do.
They can be because, yeah, what's hard about these kind of loops is sometimes you have to do what's known as a priming read. And a priming read is when you got to get the data before you even enter the loop, and then you got to do it again inside the loop. Something like this. Cout less than quote, enter a number or -1 to quit. Colon, space, end quote, semicolon. And let's store that number in to I. So CIN greater than I. And this will be the last thing we do. We're getting close to 9:45. All right. And we're going to keep running while I is not equal to -1. Because if they type in -1, we wanted to quit. And I don't know what we're going to do with I. So cout less than you typed. Let's use printf. We're on a printf kick. Printf parentheses quote you typed %d period. Cool exclamation mark \n. End quote comma I in parentheses semicolon. But now we got to get our data again. And that's what's weird about sentinel loops, or a lot of different kind of loops like this, is that you have to do one read, one input here, and then you got to do it a second time before the end of the loop. Now if you use a while true loop in an if statement, you can avoid that to where you only get the input in one place. And I like doing that, but this textbook doesn't show doing that. Our scripting classes book does, for which I appreciate because it's my favorite way of solving this kind of sentinel loop problem. And there we go. Enter a number or make -1 to quit. Okay, 100. You typed 100. Cool. 200, 300, -1. What if I run it and I type in -1 right to begin with? Is it going to print you typed something cool? What if I typed in -1 right here? Is it going to get to here? I know me and Q and Serena know because they answer all my questions. Somebody tell me. If I type in -1 here, but my while loop says while I not equal -1, is it going to print that? Okay, y'all can tell me. And no, it's not going to print it. Why? Because if I is equal to -1, it's a pretest loop. So it can't even get in here. Let's prove that. Didn't print it, right? So this is called the priming read. If you took fundamentals from Donna, you probably hit that. That's the priming read. Priming the pump. And then you got to do it again. If you write your loops like this. Or you can use a while true loop. While parentheses true. And what does while true mean? This is a test that never turns false, so it's an infinite loop. Except we're going to put a break statement in to stop it from being an infinite loop. Now just take these two statements right here and copy them. That cout, enter a number or 1 to quit, and cin greater than I. But now we're going to check. What if they typed in -1? If I equals -1 in parentheses, break. Break out of my while loop. And then take this print statement and put it after the break. And let's change this text here from enter a number to something that looks a little bit different, because otherwise it'll look like it's part of this loop. So how about we make it say, okay, comma, now enter a number. Just so it looks different. All right, this is a sentinel-based loop that does not have the priming read. It does not have the input statement in 2 places.
So you have to do it twice and it says don't bound you, or else it's going to screw up.
Or you use a while true. Either way. All right, enter a number -1 to quit. So 10, 20, 30, -1. It exited that loop, and now it's saying, okay, now enter a number, or -1 to quit. 10, 20, 30, -1. These loops do the exact same thing, although logically they are different, right? I mean, they're arranged different, but their behavior is the exact same. Whichever one makes more sense to you is the way you should do it. Now, both of them make sense to me, but I like this one better. I like this one a lot better. Just because I don't like having repeated code. I don't like having that and that, right? 2 bits of stuff right in the that are identical. I'd rather just have that once.
A while true or whatever.
Yep, a while true loop is an infinite loop unless it hits a break. The break kicks it out of the loop, so when they finally type in a -1, it leaves. All right. Now we did a lot of cool stuff today, but we didn't really get very far through the PowerPoint, which is okay, because learning about classes and structures and pointers and printf is really important stuff, even if it's not in the book. So I don't think we covered enough to actually do any more homework based on it, but I think that that's okay. So no homework assignment for today.
Alright, when is homework 11 due?
I don't know. Does it have a due date?
Training. I think so.